the inspector's concern is valid. A mud ring is not designed to support the weight of an electrical box and its contents. Should the mud ring be removed, the box could become loose and fall into the wall, creating a potential electrical hazard. TIG welding the electrical box to the mounting bracket is an acceptable solution because it provides a secure and permanent connection. The weld will not only support the weight of the box but also prevent it from becoming dislodged if the mud ring is removed. While there is no specific code requirement that prohibits the use of mounting brackets to support electrical boxes, the inspector's interpretation of the code is based on the principle of safety. Welding the box to the bracket ensures that the installation meets the intent of the code, which is to minimize electrical hazards. Although the inspector's stance may seem overly cautious to some, it is ultimately based on a valid safety concern. By welding the electrical box to the mounting bracket, the installation is safe and code compliant. This eliminates any potential risks associated with loose or unsupported boxes. Electrical codes prioritize safety, and inspectors are tasked with ensuring installations meet those standards. Sometimes, this means interpreting codes in a way that goes beyond the literal wording to address potential hazards. In this situation, the inspector's concern about the electrical box falling into the wall if the mud ring is removed is a valid safety concern. Mud rings are primarily designed to provide a surface for mounting devices like switches or receptacles and are not intended to bear the full weight of the box and its contents. Over time, the mud ring could weaken or become dislodged, leading to the box becoming unsecured. The proposed solution of TIG welding the electrical box to the mounting bracket addresses the inspector's concerns in a practical and effective manner. TIG welding creates a strong, permanent bond between the box and the bracket, ensuring that the box remains securely supported even if the mud ring is removed. This method provides a redundant support system, enhancing the overall safety and reliability of the electrical installation. From a code compliance perspective, while there may not be a specific code provision that explicitly mandates welding the box to the bracket, the inspector's interpretation is based on the overarching principle of electrical safety. Electrical codes are designed to prevent electrical shock, fire hazards, and other potential dangers. By requiring the box to be securely supported, the inspector is ensuring that the installation minimizes the risk of these hazards. Welding the box to the bracket demonstrates a proactive approach to safety, going above and beyond the minimum requirements to provide a more robust and reliable installation. There are several factors to consider when evaluating the suitability of different methods for supporting electrical boxes. Firstly, the weight of the box and its contents is a crucial consideration. Electrical boxes can contain numerous wires, devices, and connections, which can add significant weight. The support system must be able to handle this weight without sagging or failing over time. Secondly, the environmental conditions in which the box is installed must be taken into account. In damp or corrosive environments, the support system must be resistant to rust and corrosion to prevent weakening and failure. Thirdly, the ease of installation and maintenance is also an important factor. The support system should be relatively easy to install and should not impede access to the box for future maintenance or repairs. In some cases, alternative support methods may be acceptable, such as using additional screws or fasteners to secure the box to the wall framing. However, these methods may not provide the same level of security and long-term reliability as welding. Welding creates a permanent bond that is resistant to vibration, impact, and other stresses that could potentially loosen other types of fasteners. It is also important to note that the inspector's interpretation of the code may vary depending on the specific local regulations and practices. In some jurisdictions, inspectors may be more stringent in their enforcement of safety requirements, while in others they may be more lenient. It is always best to consult with the local electrical inspector to ensure that the proposed installation meets their specific requirements. Ultimately, the goal of any electrical installation should be to provide a safe, reliable, and code-compliant system. By taking proactive steps to address potential hazards and ensure that the installation meets the highest standards of safety, electrical contractors can protect themselves, their customers, and the public. In this case, welding the electrical box to the mounting bracket demonstrates a commitment to safety and provides a robust and reliable solution that addresses the inspector's concerns. The decision to weld the electrical box to the bracket might also depend on the specific type of wall construction. For example, in drywall construction, the drywall itself offers limited support for the box. Therefore, a more robust support method like welding might be preferred to ensure the box remains secure over time. On the other hand, in solid concrete or masonry walls, the box might be adequately supported by anchors or fasteners alone, and welding might not be necessary. The type of electrical box being used also plays a role. Metal boxes, especially those made of steel, are more easily welded than plastic boxes. Welding plastic boxes can be challenging and may not result in a strong, reliable bond. In such cases, alternative support methods might be more appropriate. Furthermore, the specific welding process used can affect the strength and durability of the weld. TIG welding, also known as gas tungsten arc welding, is a precise and controlled welding process that produces high-quality welds with excellent fusion. It is often preferred for welding electrical boxes because it minimizes the risk of damaging the box or creating excessive heat. However, other welding processes, such as stick welding or MIG welding, may also be used depending on the availability of equipment and the skill of the welder. Before welding any electrical box, it is essential to ensure that the box is properly grounded to prevent electrical shock. The grounding connection should be made in accordance with the applicable electrical codes and standards. Additionally, the welding process should be performed by a qualified and experienced welder who is familiar with the safety precautions and best practices for welding electrical equipment. It is also important to consider the long-term maintenance of the electrical installation. While welding provides a permanent connection, it may make it more difficult to remove or replace the box in the future if necessary. Therefore, careful planning and consideration should be given to the placement of the box and the potential need for future access or modifications. In some cases, it may be possible to use removable fasteners or connectors in conjunction with welding to provide a balance between security and maintainability. The inspector's emphasis on safety is a reminder of the critical role that electrical inspectors play in ensuring the safety of electrical installations. Electrical inspectors are responsible for verifying that electrical work is performed in accordance with the applicable codes and standards, and that it meets the required level of safety. They are trained to identify potential hazards and to ensure that they are properly addressed. Electrical contractors should view inspectors as valuable partners in the process of creating safe and reliable electrical systems. By working collaboratively with inspectors and addressing their concerns proactively, contractors can help to ensure that their installations meet the highest standards of safety and quality. In addition to welding, other methods can be used to enhance the support of electrical boxes. Firstly, using larger or heavier gauge mounting brackets can provide increased strength and stability. Secondly, installing additional screws or fasteners to secure the box to the wall framing can distribute the load and prevent sagging. Thirdly, using adhesive compounds or sealants can provide additional bonding and support. However, it is important to select adhesive compounds and sealants that are compatible with the materials of the box and the wall and that are rated for electrical use. Another important consideration is the proper wiring of the electrical box. Overcrowding the box with too many wires can put strain on the connections and potentially lead to overheating or short circuits. Electrical codes specify the maximum number of wires that can be safely installed in a given size of electrical box. It is essential to follow these guidelines to prevent electrical hazards. Additionally, the wires should be properly secured and supported within the box to prevent them from becoming loose or damaged. Wire connectors should be used to make secure and reliable connections between the wires. The connectors should be properly sized for the gauge of the wires being connected, and they should be installed in accordance with the manufacturer's instructions. In addition to the technical aspects of supporting and wiring electrical boxes, it is also important to consider the aesthetic appearance of the installation. The box should be installed flush with the wall surface and should be properly aligned. The cover plate or device should fit snugly against the wall and should be securely fastened. The overall appearance of the installation should be neat and professional. In summary, supporting electrical boxes requires careful consideration of several factors, including the weight of the box and its contents, the environmental conditions, the type of wall construction, the type of electrical box, and the applicable electrical codes and standards. Welding the box to the mounting bracket provides a robust and reliable solution that addresses the inspector's concerns about safety and code compliance. However, other methods can also be used to enhance the support of electrical boxes, depending on the specific circumstances. By following best practices and working collaboratively with electrical inspectors, electrical contractors can ensure that their installations are safe, reliable, and code compliant. Finally, the importance of ongoing training and education for electrical contractors cannot be overemphasized. The electrical industry is constantly evolving, with new technologies, new codes, and new best practices emerging all the time. Electrical contractors must stay up to date on these changes to ensure that they are providing their customers with the best possible service and that they are meeting the highest standards of safety and quality. Ongoing training and education can help electrical contractors to improve their skills, expand their knowledge, and stay ahead of the curve in this dynamic industry. This might involve attending workshops, seminars, and conferences, reading industry publications, and participating in online forums and discussions. By investing in their own professional development, electrical contractors can enhance their credibility, build their reputation, and ultimately grow their business. Moreover, it is important to document the welding process properly. This documentation should include the date of the welding, the name of the welder, the type of welding process used, and any relevant inspection results. This documentation can be valuable in the event of future inspections or audits. It also demonstrates a commitment to quality and safety. The welding process should be performed in a well-ventilated area to avoid inhaling fumes. Appropriate personal protective equipment such as a welding helmet, gloves, and a respirator should be used to protect the welder from hazards. The welding area should be free of flammable materials to prevent fires. Before starting the welding process, the electrical box and the mounting bracket should be thoroughly cleaned to remove any dirt, grease, or rust. This will ensure a strong and reliable weld. The surfaces to be welded should be properly aligned and clamped together to maintain the correct position during the welding process. The welding current and voltage should be adjusted to the appropriate levels for the type of metal being welded and the thickness of the materials. The welding process should be performed in a controlled manner to avoid overheating the metal or creating excessive spatter. After the welding process is complete, the weld should be inspected for any defects such as cracks, porosity, or lack of fusion. Any defects should be repaired before the electrical box is installed. The weld should be cleaned and finished to remove any sharp edges or burrs. The electrical box should be tested to ensure that it is properly grounded and that there are no electrical shorts. The electrical box should be labeled to indicate that it has been welded and to provide information about the welding process. Finally, it is important to remember that electrical work is inherently dangerous and should only be performed by qualified and experienced professionals. Working with electricity can be life-threatening if not done properly. Always follow the applicable electrical codes and standards, and always take the necessary safety precautions. By doing so, you can protect yourself, your customers, and the public from electrical hazards. And also, the box is securely attached to the building structure, preventing any movement or strain on the electrical connections. This reduces the risk of loose connections, which can cause overheating, arcing, and even fires. Welding also provides a degree of protection against tampering or unauthorized access to the electrical box. It would be more difficult for someone to remove the box without specialized tools or knowledge. The welding process can also help to seal the box against moisture and dust, which can corrode electrical components and reduce their lifespan. However, it is important to ensure that the welding process does not damage the box or compromise its integrity. In some cases, it may be necessary to apply a protective coating to the weld to prevent rust or corrosion. Another benefit of welding is that it can be used to create custom mounting solutions for electrical boxes. This can be particularly useful in situations where standard mounting methods are not feasible or practical. For example, welding can be used to attach electrical boxes to unusual or irregular surfaces. It can also be used to create reinforced mounting points for heavy or oversized electrical boxes. The cost of welding electrical boxes can vary depending on several factors, including the size and type of the box, the complexity of the welding process, and the hourly rate of the welder. In some cases, welding may be more expensive than other mounting methods. However, the added safety and reliability of welding can often justify the additional cost. It is important to obtain multiple quotes from qualified welders to ensure that you are getting a fair price. In addition to the cost of welding, it is also important to consider the time required to complete the welding process. Welding can be a time-consuming process, especially for complex or intricate welds. It is important to factor this time into your project schedule to avoid delays. Welding can also create a significant amount of heat, which can damage nearby materials. It is important to protect surrounding surfaces from heat damage by using heat shields or other protective measures. Welding can also generate sparks and fumes, which can be hazardous to your health. It is important to wear appropriate personal protective equipment, such as a welding helmet, gloves, and a respirator, to protect yourself from these hazards. Welding should only be performed in a well-ventilated area to avoid inhaling fumes. Welding can also be noisy, which can be disruptive to neighbors or other workers. It is important to take steps to minimize noise pollution by using noise barriers or other noise reduction measures.